Hey guys, I'm your Civil Pro. So welcome to the second day of this particular lecture on the building design using STAAD.Pro. So before we start, I'll just ask you a particular question. So today's question is, what is the full form of STAAD? So this is a very common software and very much use it. So for the building design, so what is the full form of STAAD? If you know it, just answer below in the comment section. The right answer I'll give a heart. Okay. So now just go to our particular lecture. In the previous lecture, we had designed this entire model, and what is important because in this model you can see there are many informative videos on STAT in the YouTube and in the paid courses as well. But you find that some people are not considering these things, delicate things which you need if you want to go for structural vetting. Like we would need to consider the plinth depth, plinth height, and the foundation depth, the staircases, and the headrooms as well. So because when you are going for vetting a project, either some other engineer will check, especially for government projects, you need to go for structural vetting, and other professors, probably professors of some educational institutions or government institutions will check your STAD model, and even in some municipality approvals also they check. So for that you need to make sure your model has all the load combinations considered, all the model delicacies considered. So you need to consider this, like I had tried to tell you in the previous video. So if you haven't watched the video and completed the previous lecture, make sure you watch it and complete the lecture, and after that you come and attend this lecture. Okay. So for now, just you have this particular model, everything is fine. Whenever you open new stat file, just you can just run analysis. I have not assigned loads, anything, just I've just run analysis, just simply check whether everything is okay or not. And the first thing which you need to do is we need to assign the properties of our plates. So for assigning the properties of our plates, we'll go to our option of your general, and in general, we'll just define this thickness here. We will not design the slab, but we need to assign the properties of the plate since you've assigned the plates in the model here. So this plate element thickness, we'll just go here and define 0.15 and then click on add, and then click just close this, and then okay, this hasn't been added. Okay, so go to thickness and 0.15 and then click on add. So now it is added. Just close this and select this and assign to view, because all the this plate thickness, wherever there is plate, it will be assigned. And yes, now you can check any properties are remaining. Just go to select missing attributes and missing property. So the no property, nothing is found. So every element's property has been defined. Okay, so no problem in that. And after you define the property, you can just simply go to this particular assigning of your loads. So for assigning loads, go to loads and definitions. First of all, you can see this is a 6-meter building, and 6 plus 2.4. If you just add it, then the answer will be 8.4, including the headroom. So less than 10 meters, no need to define the wind loads, only the seismic load you need to define. Go to seismic, click on add, and select this 2000 to 2005. Okay, and then click on generate, and then just this, and this building is in zone 5. Always select SMRS, special moment resisting frame. General building for now, if it is an important building, government building, important building, hospital, etc., you just need to do it. I'll or make a video on the code. Everything is mentioned in the 870 in this particular code, IS 1893. Medium soil, just this is not a genuine software, so just do 0.5. That means 0.05 will come. 5% is okay, but I'm just doing 0.5 because it shows like that. I just click on this generate, and then uh, uh, after just doing that, after having done that, so just you need to click on your add here, and after that, after click on add, just as a self fit factor 1. Remaining things also need to do, but we'll do it later, right, in the stat editor. That's easy because we want the easiest and fastest process. Then click on this load case details, and select always the first load which you'll add. Make sure that this is the seismic load. So this is seismic load in X directions, SLX. I'll just add here. And second, also make sure there's a seismic load in Z direction, seismic load Z. Now I don't need to save. Click on add here. And third, always select the dead load here. 875 part 1 dead load TL, and then click on add. And this next one, just live load, live, select this LL. and then click on add and then close it. Okay, so dead load, live load, these things are added. And now we'll define this seismic load here. Click on add here, and this will be in the obviously in the x direction. The vector is 1, and then click on add, close it. Seismic load here, click on add, and this is obviously seismic loads in z direction, and the factor is 1, and then click on add. Okay, so one wrong thing we did here, we just need to delete this. Again, seismic load x, and click on add. This we hadn't done in the seismic, so go to this seismic loads x direction and 1, and then click on add. So z direction 1 and x direction 1, this is done. Then dead load. Now dead load, before applying the loads, dead loads, I'll tell you there are two types of dead loads. One is the load which will be to the floor finish, which will apply in this floor, and this floor, not in this floor, because this is the plinth level. And here there will be compacted earth, and after that all the loads will go to the compacted earth. So no need to apply live loads and a load due to the slab here, because there will be no slab, only PCC or DPC will be there. So there will be the load due to the wall, and there is a very briefly I'll just show you in the calculator. Brick wall load is 19, plaster load is 20, maximum load, and the wall thickness is your wall height is 3 meters. Okay, and the beam is 0.35 meters. So the total height remaining is 3 minus 0.35, which is 2.65. So the volume of the wall, if you see 125 wall, 20 into 0.125, into your 20 into 0.125 into 2.65, which is the height of the building. So this will give you an approximate result. So it is 6.625. So I'm considering 7, right? 7 I am considering for the load here for the walls. For all the positions where we have the walls, I'm considering the 7 kilonewton load. So dead load, I'll click on this add here. Similarly, for this particular parapet wall load, I'm considering 3. I can also calculate 20 into 1 meter wall height. I'm considering 1 meter wall height into the thickness of this your wall. For parapet wall, I'm considering 150 mm thickness into 0.15, and this is coming as 3. So I'm considering as 3. So if you're wondering what is 20, 20 is the unit weight of mortar, 19 is the unit weight of red brick. So I'm considering the higher side. Like this, you can do this pretty easy calculation. You need to know that. If you want to make a separate video on that, just comment below. I have a separate video to explain it. Okay, no problem in that. Dead load here, I'll add 2 types of dead load here. First, go to this member load, and here one, since this is the down acting from top to bottom, it will be -7. The first type I'm adding, and the second type I'm adding -3 for the parapet wall. Click on add, and I'm adding the floor finish load. So it will be the floor load. Floor finish load for the tiles, marble, anything, or plain PCC which we give. Floor finish load is -1 maximum as per 875 part 1. Maximum is 1 kilonewton per meter square. So I'm adding this, and since I'm not considering the already considering the slab items, so I don't need to consider the load of the slab here. Otherwise, I need to consider the self weight of the slab also. I've already provided the slab items, so no need to consider the load of the slab items here. Okay, so this is done here, and after that I'll just close this, and live load also I'll just take the live load from here in the STAAD editor. I'll do it, so no problem in that. So 7 kilonewton per meter, this Y range, I need to change the range of this. So this thing will act from this Y range will act from, let's start from 2.5, and the minimum and the maximum range. Since we know this is a 9 point something meter building, maximum range, let it be your 6 point something, because we don't need to apply dead load beyond that point, 6.2, and then change it. Now we can see this particular range of this floor load is applying these 2 floors. In the top floor also, if you want to apply, then you can also add the floor load there, but no need to apply the floor load there. Only the normal slab load will be enough for the headroom. Okay, so that is the case. If you want to apply it also, you can apply, no problem in that, but we have done it. And this 3 kilonewton and load will apply in the topmost floor. And so let's start from the top. We'll go to the front view, select this particular view, and go to select, go to this selected objects view, go to view selected objects only, and just go to the top view. And here in the headroom portion, since 7 is selected in the headroom portion, we'll go and do the 7 here, and do the 7 here, because there will be headroom here. So assign to selected beams, assign and yes, and take the 3, and the 3 will apply here in the remaining part. Okay, for the parapet wall, assign to selected beams, assign and yes. So this has been assigned, and then we'll go to view whole structure, and then go to the front view. Just to say, take this particular floor and view, and I think we can take both. Okay, let's go one by one. View selected objects only. Where is it? View selected objects only. Go to this top view, and then click on this 7, and the 7 we have this. Press Control and press this, and we have this. We have this. We have this. We have this, and we have this as well, and this and this. In this portion, there is no wall in the plan, you can see, so no need to assign it here. And assign to selected beams, assign and yes. Here we have done, and again we'll go to view whole structure. Go to the front view and select the bottommost floor here, and select it like this, and view selected objects only. Go to the top view, and where you can easily apply the loads here. 7 kilonewton has been selected, and here actually select this thing, select this, select this, select this, 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 and this. After that, assign to selected beams, assign and yes. This has been done, and when this things have been done, now we need to copy this to the live load as well. So we simply go to the STAAD. First of all, save the file, and then click on save. Then go to the STAAD editor, and then here we'll do some shortcut. What we'll do, we'll go to the flow load, and this flow load, what we'll do, we'll just copy this, and in the live load, I'll just copy it from here, and this load not be -1, -2, 2 kilonewton per meter square for the residential building. Just save this file and close this, and you'll see the magic live load has been assigned, so no problem in that. Now the seismic load also, these definitions also will define it by the STAAD editor. Before that, let me just explain a brief concept to you. I think it will be necessary. So now the seismic load takes into consideration your live load and dead load. We all know that the live load and dead load will be taken into the consideration. So first of all, the dead load, whatever the actual dead load we have for all the members will be taken. So no problem in that, and there will be no sign. Okay, sign convention negative things, and we don't need to give GY and all these things. We don't need to give here. Okay. And the second thing which we need is the load consideration of the slab. So since we already have defined the slab element and the self weight, so self weight it will take automatically. So don't need to define the slab element of the slab, because in some builds you'll find they are taking the slab as suppose the slab height is 0.15 meter slab, and then it will be your 25 into 0.15. And they are taking the slab element of 25 into 0.15 means your 3.75 kilonewton per meter they are taking. But here I have defined the slab item, so no need to take that. The self weight it will consider automatically. So I hope you're clear with that. And then we need to assign the live load. So live load, if live load is above 2, then you take 50%. And if it is below 2, then you take B2, or below 2, then you take 25%. So live load is 2 kilonewton per meter square. So in the seismic load consideration, we'll take the 25% of this particular value, 25%. So 25% is actually, this will be your 0.5. So 0.5 live load you have to take, this we have to take, slab we don't have to take, and dead load actual we have to take for the seismic load. These things we have to take. So I'll just get back to this screen and I'll show the shortcut directly. I'll not show you the long process because that's not required. Just use the shortcut process. Go to STAAD editor. And first of all, I'll copy the I'll see where the damping ratio is. Damping ratio is 5%, and this damping ratio is 0.5 or 5% is pointing ratio, damping ratio. So here I can see DAMP equals to 0.05. So this is the actual thing. So this is not a genuine software. That's why this problem comes. So 5% is 0.05. Make this 0.05. No problem in that. After self weight, give this a enter, and after giving it an enter in this member load, just as you can see, this is member load is a load on the beams. So just copy the same thing here, and only just to make this member load as a member weight, WEIGST. Change the spelling of this, and -7 you need to keep the magnitude, and minus and GY just remove this. UNI load is there. Now this parapet wall load also minus and GY, just remove this. So now the first part is done. Now the live load addition. So live load addition, you can see in the live load we had added this live load here, the flow load part. Just copy this and paste it. Just go here and paste it here, and same thing. Just make this as your weight load. Make this WIGST weight, and this GY. Just get rid of this GY, and minus sign, you just get rid of it. The magnitude will be 25%. That is your 0.5. So 0.5, you are adding this live load. Just save this, and after saving this, just close this. If there is any error, it will show it here. And the definitions here, you can see the seismic definitions. This will be added here. This member load of 7 and 3, this both are added. The floor weight is also added. This is not show, but it is added. And the seismic load in X direction, this is done. This is in Z direction, this is done. Dead load, this is done. And you can see the blue ones are the ones which has been selected. Actually, this parapet wall you can see here, and the green ones are not selected. Okay, like this you can distinguish. Live load also, you can see live loads are applied on this two floors. You can rotate the model using the cursor of your screen. Just select the model in the cursor of the screen. You can rotate it, and then also you can just see where the live loads are applied. And after that, you need to go to this load case details, and then click on this add. And here auto load combinations, just to simply select this. No need to define combination 1 and 1 by any other method. Go to general structures and click on this generate loads, and click on add, and then close. And after that, go to your analyze and run analysis, and then save the model and run the analysis. If there is any error, it will show like this. You can see the error process also. So these are the some of the error process, but before I just run the analysis just to check now. Okay, so but there are some steps which are remaining. Okay, this finish command is not there. This can be easily fixed here. So now before running, I just checked whether there is any other error. So before that, you need to define some things. So go to design, because I have not defined the design properties. So what will be the code we used and etc. So just go here and select this. First of all, select this concrete here. Okay, concrete you have to select, and after that you have to select the Indian code here. Indian IS 456 you have to select. Because we are designing by the Indian codes, we're designing by other codes, you can select the other codes. So then select the parameters, all the parameters you select from here. And here we need to select some things which are compulsory. Depth and clear cover. We select compressive strength of concrete. We need to select clear cover. We need to select, and then FY main, FY secondary. The this grade of steel. Minimum main, minimum secondary. This is also very important. And minimum secondary size, minimum. This one is also very important here. And all these things, when you have selected, just they do this and click on OK, and then click on define parameters. Clear cover, I am taking 0.04 meter, that is 40 mm for both the beams and columns. Just click on add. This clear cover of concrete, I am taking as composite strength of concrete, I am seeing M20 concrete, 20,000 kilonewton per meter square. Click on add. FI main, I am using Fe500 steel, so 500 123 kilonewton per meter square. FY secondary also Fe500 steel is used, so 500 123, and then 500 123, so to make sure the zeros are okay. Okay, then click on this add, and then maximum main, I'll go with the 20 mm dia. Click on add, and maximum secondary, I'll go with 12 mm dia or 10 mm dia. Add, and minimum main I'll go with 16 mm dia, otherwise okay. And minimum secondary I'll go with 8 mm dia. Click on add and then close it, and then go to commands. Don't want to design the slab here. Design beam, design column. Uh, I hope this is added. Takeoff. Okay, add. Now you can see all these things you need to define here. Design beam, design column. Okay, this is added. So clear cover, just select this and go to front view, and first of all select the beams. I've selected this, selected this, selected this, selected this. Okay, and then go and select beams parallel to Y. So this has been selected, and then this and this made beams. Just see the effect in the 3D view. All the beams have been selected and then assigned to selected beams, and assigned. FE 500, this you can, all these remaining things you can assign to view. Steel also will be used everywhere, so assign to view. This also will be used, steel everywhere, steel everywhere, steel. This one also will be used everywhere. This one also will be used in the entire structure. This is also steel, entire structure. Beams, you need to just select the beams, go to the front view and select the beams. Very carefully, just using control, just deselect the beams first. Okay, first of all, just select the main beams. Just we'll select landing slabs later. Okay, so design beams and assign to selected beams, assign, and yes, and even if the landing slab is not designed, so there is not much of an issue in that. So if you select the design beam column, the landing slab, mid landing slab, right? Only this one and this one. Okay, these two, I think. So just add this, assign to selected beams, assign, and yes. So these two are also selected, which you wanted. Mid landing beams also. So design column, this is very easy. Just go to select beams parallel to Y, and this is done. So, and assign to selected beams, assign, and yes. So this is done, and after that these things are done, and concrete takeoff it will do automatically. Go to analysis, print, you can just click on all and click on it, right? And then just close this, and after that you can just go to analyze and run analysis, and model will be saved. Obviously, if there is a you taking a long time, there will be no error here. You can stay in modeling mode or view output file just to see the takeoff here. So here you can search here, takeoff, find next. Here you can see the takeoff here. So concrete bar total volume of concrete is 20.2 cubic meter, which is be used in the entire structure, and bar dia also and weight also it is given. So here you can find the estimate of your total bar steel and things which will be using. So then like this you can see the results as well. So here you can, like this you can see the results, and concrete design you'll see. Right, double click on this concrete design. See this bar size of 16 have been used, and 8 bars of 16 has been used in this particular uh, column. And in this particular beam, you can see concrete design, 2 bars of 16 in the top, 2 bars of 16 in the bottom. Here also you can see concrete design, 2 bars of 16 in the top, 2 bars of 16 at the bottom. Here in this particular beam also, you can see the design here. So like this, we can check the design of this particular beams and slabs here. So this is the second day lecture. You just complete this step by step, and after that we'll proceed towards the foundation design, and after that we'll decide also just discuss some of the concepts. And if you have any doubt in this, just I have the comment section open. Just comment below and I'll try to give you a solution to that. Okay, so see you in the next lecture, and subscribe to this channel for further updates. Thank you. Bye bye.